Hi, if you are developing your product using microservice architecture, then you're probably familiar with event-driven architecture as well. But do you implement it in a good way or in a bad way? My name is Hendrik, I'm from Blankon Technology Solution, and in this video, we will talk more about how do we implement event-driven architecture inside our projects. Alright, let's go a little bit back into history. So these are the diagrams of how the old way we used to display a real-time data. So inside this diagram, let's assume we have message service here. So message here means like your Facebook account messenger or maybe your Instagram DM. The purpose is how do we display the latest data from the back end into the message service. So in this case, will be the front end. The old way is we have kind of API requests to back end every 15 seconds or whatever the configuration is. So this way, we will always call the API, and from that API, we always display the latest data into the message service. That's what we do for the web application, or maybe let's say the mobile app or something. With the same approach, let's move into how do we implement this into the microservice. So let's say you have analytics service where when user does some behavior on your website, the event and everything will be stored inside this specific service. And you have another service called the machine learning model. So machine learning model every 3 hours will do some API request to the analytic to grab the latest data from the analytic service. That's kind of the same approach, but the specific approach is within inside the microservice level. From this implementation, you can see that it's really not an efficient way to do that. For just displaying the real-time data, that should be fine because you can grab whatever the latest data and display it inside the service. But for the microservice one, that will be a little bit complicated because with the ML model do the request to analytic every 3 hours, they have to slice what the latest data they get from the previous API call, how to manage the state and everything. So that will be a little bit more complicated inside the microservice level. So the new way to do this is by using event-driven architecture. Instead of the message app do an API request to backend every 15 seconds, let's try to do the other way around. And here, whenever backend has new data of the message, it will push the data into the message app. So message app here will be a passive service just to receive the new data and display it into the front end or maybe service. This is the kind of the same approach what your phone notification work. This is what we call the push notification. So if you pull the same scenario into the microservice level, pretty much the same approach. When analytics service has new analytic data, it will push the data into the machine learning model here. Now, machine learning model only has to care about the new data without basically what he did is checking what is the latest data from API call, the previous API call. And right now, basically, there's no worries at all for that. Just store the new data and process it into the machine learning model. The push method here could be done in multiple ways. Some basic and common implementation is via internal API call between services, or maybe a remote procedure call between those services. But the problem, one of the biggest problem with this implementation is when you try to send the data with from the backend to message app, and at the time the message app is down. Once the event sent into the message app, it will be failed because basically the service is down and can't receive any data. But so how is the way that you can maintain or handle this specific problem? If this failed, you could probably just retry to send the data again. That's fine if you do everything in asynchronous way, but if you do everything in synchronous way, that will be a big problem because user has to wait until this specific push to be succeed, then they continue to the next process. Another problem occur by using the specific implementation is when, let's say, you have new service that require to receive the message data from backend here. So that will be another push. With API or remote procedure call, you have to change code inside the backend from previous one that you only need to send to one specific service. Then you have to change the code. Now you have two lines of code. First one to send to message app service and the second one to send to the new service here. So this is quite hard to maintain as well. Our favorite way to do the event-driven architecture is this way on this specific diagram. So between two services, analytic and machine learning model, we will have another service in between them. This is what we call the message broker. Normally we will use Kafka if it's a kind of a lot of big data to send, or for less data we will more prefer to use RabbitMQ for the message broker. So this is the updated diagram when we start using message broker. The analytics service will send the data into message broker first, and message broker will send the data into related service that need this data. In this specific case is machine learning model. Okay, let's really understand how everything works together. First thing that you have to know is what is the producer and what is consumer. Producer basically a service that produces the data and send it into message broker. In our case here, the producer is the analytics service, and consumer is the service that receives the data from message broker. In our case here is the machine learning model. So this is what we call the consumer. The next thing that you have to understand is about topic and subscribe. So let's go with topic. If you try to imagine an email, each email has a subject, and you can assume the topic here is the subject of that email. So every data that's sent from producer must be under a specific topic. Let's say producer here send a click data under a specific topic. Let's say click event. And producer only care about sending the data into the message broker. The rest is what message broker will handle. Next, about subscribe. Since producer doesn't care about where the message or the data will be sent to, it's now that consumer has to take care about that. In order to receive specific data from producer, consumer has to subscribe to specific topic here. So this will solve the problem when you have new consumer with API integration or internal API integration that we talked before. They have to update the producer stuff. But with message broker, when you have new service that need the same data, you can just subscribe to the same topic that required. So it will be automatically message broker will also send the data into the new service. So now it's more easy to maintain your whole infrastructure when new service need the same data from the producer. You don't have to go to your producer code and update your code to send the same data to new service. With message broker, when new service subscribe to specific topic, then that will be automatically receive the data out of the box. Next, what about the other problem when the service is down? How do we maintain it? Let's say the producer sent specific data to message broker, and we have two subscribers here. So it will send the first data and for both, since both are still up. And here comes the second data, since both are still up as well, it will receive the second data. And suddenly our new service here stopped working. When the time it stopped working, message broker will immediately know, oh, this specific service is down now. And producer want to send another data, which is the third data. Since it's up, it will receive this third data, but since it's down, it won't receive anything because it's basically down. And producer also want to send another data, the fourth data. It will be here, but not here. And after some times, this new service is up and running again. So what will happen is, message broker will check, oh, now this service is run, what are the data has been sent from producer that this specific service hasn't received yet. And by that, message broker will send the data for 3 and 4. So that's how it solved the problem when your service is down, and message broker is still very smart to handle that specific problem. Alright, let's use the same problem when one of your services is down, and let's see how it's behaved inside the code. This demo I will show you the same architect with before inside the example. So we have one publisher that sends some specific message into this topic. So this is from our env file. This is the topic, new market data, and we have two consumer here, the consumer test and consumer test 2. Both subscribe to the same topic here for the new market data. The second one also with the new market data. So let's run the consumer. I have the terminal here and also this one. Okay, once we fire an API here, it will directly send it into our consumer. Let's do the same thing that we explained before. First one, we will send two data with both services are on. This is the first one. The second one, just to make it obvious, we can change all the value to 2. This is the second one. And we could see we got the first one here and the second one for the consumer 2. The consumer one also to get the same thing. They get the first one and the second one. Now let's turn off one of the consumer here. So at this point we have our second consumer down, but the first consumer is still up here. And let's send more data. Let's send the third data just to make it obvious, and the fourth data. So let's see first consumer. First consumer got complete 1, 2, 3 and 4, and our second consumer is down. Now when we try to run our second consumer, because we already got the first and second, we're supposed to get the third data and fourth data right away after the consumer is up. Yep, it got the third data right away and the fourth data right away. So basically how this behave inside the our like a demo product right now. Alright, that's how we implement event-driven architecture inside our project. If you have any thoughts about how you run yours, you can put that inside the comment, or if you have any questions related with our video, don't be shy to put your question inside our comments. That's it from me for today. See you on the next one.